Okay, so welcome to section 2.2, which is graphing linear functions. So graphing linear functions. Okay, so let's recall that the slope of the line, of course, is rise over run, right? So the slope m, pardon me, the slope m is going to be rise over run, which of course is the change in y over the change in x. So let's note, so given any point P, so given any point P, let's call it x comma y, on the graph of f of x, or on the graph rather, the graph of a linear function, a second point Q, so a second point Q can be found as Q is going to be at x plus delta x, comma y plus delta y. So for example, let's use the slope, to plot the graph. The graph of the following functions, So number one, let's say we're given that point 3 comma negative 2 is on the graph, is on two different words, is on the graph. And the slope, let's have the slope be 2/3. Okay, so my slope, 2/3, we know that that's going to be delta x over delta y. Whoops, boy, holy frioli, shame on me. Rise over run, not vice versa. Delta y over delta x, rather. There we go, got it right this time. Okay, and we were given that was 2/3. Draw that line a bit better. So 2/3. So I know that I rise to run 3. So another way of saying this is that delta y is 2 and delta x is 3. So if I'm given that point P is 3 comma negative 2, then these three together imply that point Q, what color should I use for point Q? Oops, maybe I'll do a dark yellow. So point Q is going to be 3 and negative 2, to which we're adding delta y in the y coordinate and delta x in the x coordinate, and I should have given myself more room there. Of course I didn't. There we go. Looks a bit better. Okay, so what is point Q then? Well, this is 3 plus 3. So 3 plus 3, comma. And this will be negative 2 plus 2. Where am I going with this? Plus 2. So when all is said and done, we get that the point Q is going to be 6, 0. Okay, well, let's see what happens when we plot this point. Let's plot the point P and the point Q using rise over run. 1, 2. So let's say we've got something like so. Actually, maybe I should go down a bit farther on my y-axis. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 1, 2. Okay, so we have that the point P is at 3, negative 2. And we have that the point Q is at 6, 0. Shoot, I did not leave myself enough room. I always never plan correctly. 4, 5, 6, there we go. That'll do on the x-axis, but let me move this a bit to the left. Okay, so if I rise 2, so my delta y, my rise is 2, and if I run 3, so my delta x is 3, do I get to point Q at 6, 0? So let me label. This is point P, and this is point Q, and if I rise and I run, I do indeed intersect the points. Okay, so there we are. Rise over run. Let's do another one. Okay, so subscript number 2. Let's say we have that the point P at 1, 3 is on the graph. And with the slope, let's have m be equal to 4. Okay, and so now let's look at m in orange. So m is in orange. So m, of course, is the rise over the run. So let me get this correct. This time rise is delta y, which I claim is 4, over the run delta x, which I claim is 1, because all whole numbers can be written as over 1. So I claim that this implies that delta y is 4 and delta x is 1. So we were given that the point P for this problem was at 1, 3. So these 3 items together, let me put this over here a bit, imply that point Q, no, wrong color, so point Q, which is going to be at, see if I have enough room here, 1 and 3 plus delta x and delta y respectively. So plus delta x, comma 3 plus delta y. Yep. That, of course, is going to be 1 plus 1, comma 3 plus 4. So delta x is 1, delta y is 4. So I get that the next point on the graph, if I use a slope, would be 2, 7. Okay, well let's plot this and see. So x and y coordinate axes. Oh, wow, that's weird. Why does it autocorrect so strange? So x and y. See, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 1, 2. Okay, so the point P is at 1, 3. So we're right here at 1, 3. This is a point P. Now if I rise 4, 1, 2, 3, 4. So if this is my delta y, that's a terrible delta. This is my delta y, and I run 1, that's my delta x. Do I end up where Q should be at 2, 7? And I do. So therefore I can just draw the line between them. Now mind you, this pink line is the actual graph, not the rise over the run lines. Okay, so let's recall. A few things. So in particular, f of x plus or minus k shifts the graph of f of x vertically plus or minus k units. Whereas if I had f of the quantity x plus or minus h, that shifts the graph of f of x horizontally. So horizontally by minus or plus h units. So it's counterintuitive for horizontal translation. Then next we have negative f of x reflects the graph of f of x about the x-axis. Whereas f of negative x reflects the graph about the y-axis of f of x about, that's a terrible about. Let me write this better, about the y-axis. Okay, we also have, last but not least, that f, or a times f of x, stretches the graph vertically by a factor of a, right? Okay, so using all of this, let's now plot linear functions using transformations. So for example, use transformations to plot f of x equals to x, g of x g of x equals 2/3 x. Oh, I don't know if I had enough room to write that there. Put this down here. G of x is 2/3 x, comma, h of x is negative 2/3 x, and m of x is negative 2/3 x plus 4 on the same set of coordinate axes. The same set of coordinate axes. Okay. Okay, so x and y coordinate axes. X and y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4. Okay, so first, let's look at f of x is just x. So f of x is just x. So the y-intercept is 0, the slope is 1. It is the main diagonal. Y equals to x is the main diagonal. So this is f of x. Now let's look at g of x, which is 2/3. So g of x is 2/3 x. So that means 2/3 as tall. Right? So I'm going to go up 2 and over 3. So it's going to be 2/3 is less than 1. So this is going to look more like, oops. So this is g of x, which is 2/3 as tall as f of x. Okay, so now let's look at h of x. So h of x, which is negative 2/3 x, is a reflection. So x-axis reflection, right? X-axis reflection of what? Well, of g, right? So I claim h is just a reflection across the x-axis of whatever g is. So it's a mirror image. So there's my mirror image. There's h of x is a mirror of g about the x-axis. Okay, what's left is m. So what is m? So m is negative 2/3 x plus 4. So this plus 4 means up 4, right? And what is moving up 4? H of x. So I can just look at h of x and shift everything up 4 units. So there is my m of x, and I forgot to put of x. Probably shouldn't have called it m because that looks like slope. Shame on me. But you get the idea, hopefully. M of x is just another function. Okay, so let's use transformations again to plot the next set of functions. So example, it was over 1. Okay, so example. So use transformations. To plot. Let's do f of x is equal to x. G of x is equal to 3x. H of x is equal to 3x minus 1. And m of x is equal to negative 3x plus 1 on the same set of coordinate axes. Okay. So x and y coordinate axes. X and y. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so let's look at f of x is equal to x. That'll be our main function. So for linear functions, the general guy is just the main diagonal, right? We know this. Okay, so this is our f of x. So next, let's look at g of x, which is 3 times x. Oops, I forgot to finish. Wow, okay. Trying to quit caffeine. Clearly it's not working for me. So g of x is 3 times x, which is 3 times as tall, right? So 3 times as tall. Let me put just times as tall. Okay, so it's going to be skinnier, right? Going to look something like so. So this is our g of x. So now the next function is h of x, which is 3x minus 1. So h of x is 3x minus 1. So it's just g, but it's been shifted down 1. So I take the graph of g, which is purple, and I shift him down 1. So everything gets shifted down 1 unit. So it's very close to the original one because it's so steep. So h of x. And finally, the last one, let's do m in pink. So it's m of x is negative 3x plus 1. So what's going on here? Do you agree I could factor out a negative and this would be 3x minus 1? So it's going to be an x-axis reflection of what? Well, what's inside that parenthetical is h, if I factor out the negative 1. So I take the green guy and I reflect him about the x-axis. So I'm going up 1 instead of down 1. And let's see, this guy here at positive 2 is now at negative 2. There we go. Got it. I think I've got it now. I think, did that work? Is that a good reflection? of h about the x-axis. Something like that. Okay, so this is my m of x. And what that did, hopefully, if I drew it correctly, was reflect h about the x-axis using transformations. Okay, so hopefully this makes sense. Of course, this is making plotting linear functions a lot more difficult than it needs to be because we know how to plot, inshallah. So let's consider the following. I'm going to plot two x and y coordinate axes. So let's have two x and y coordinate axes here. I'll just copy and paste this. Okay, so suppose I had a line that looks something like so through maybe some point B on the y-axis. Do you agree that no matter what value we have for x, the value for y is always b? Okay, so now let's do something over here, say a vertical line, which is just a relation, not a function. And let's say that goes through A on the x-axis. So do you agree that no matter what value of y I plug in, x is fixed at A? So theorem. Number 1. So horizontal lines are functions of the form f of x is equal to some letter b, a real number. Whereas vertical lines they're not functions, so they are relations of the form x is equal to some real number a. So for example, so let's plot f of x is equal to -3, x is equal to 4, y is equal to 2, and x is equal to -1 on the same set of coordinate axes. Coordinate axes. Okay, so x and y coordinate axes. One, two, three. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. Okay, so let's look at the first. F of x is equal to -3. So f of x is equal to -3. Okay, so that's, I know f of x is a fancy way of saying y, so that must be a horizontal line at -3 on the y-axis. So this is f of x equals -3. It doesn't matter what x is, the y value is always -3. So now let's look at x equals to 4. Okay, so let's go over to x is equal to 1, 2, 3, 4. And regardless of what value we have for y, x is always 4. Okay, so now let's go to y is equal to 2. Actually, it's not different enough. Let's use this. Y is equal to 2. Well, that, of course, is a horizontal line through y is equal to 2. X can be anything. So the height is fixed, but the left and right can be anything. Finally, let's have x is negative 1. So x is fixed at negative 1, but y can be anything, so it goes up and down as much as it likes. And there we are. Hopefully that makes sense. So now let's consider, almost there. Let's consider the following. So I'm going to draw 2 x and y coordinate axes. But actually, let's do this first one by itself. So x and y. So let's do a 3, 4, 5 right triangle. 1, 2, 3, 1, 2, 3, 4. Or 1, 2, 3, 4. So I'm going to consider a 3, 4, 5 right triangle. In particular, a line that goes through 3, 4, 5, something like so. So the slope of this line, let's call it L. The slope is rise 4, run 3. Okay. So now I'm going to call this angle here alpha, just for fun. Now let's draw another line. Let's draw this line here. Let's call this line M or N. I've been using too many M's. Make this a bit shorter. Okay. So this rise here is 1, 2, 3, and run a negative 4 for that one, for line N. And let's call this angle here beta. And let's consider the triangles that they create if I were to make 3, 4, 5 right triangles out of these. So let's make sure we know they're right triangles. Okay. So I claim that the base of this triangle here on the right has the same length as the height of the triangle on the left, and vice versa. Namely, the base of the triangle on the left is the same as the height of the triangle on the right. So these are similar triangles. What that means is that this angle up here must be alpha, and this must be beta. And that's by the side. So this is by the, let's color code it, by the side. It's actually side angle, right? Because we have, or side angle side. Let's use side angle side. I'll do that. What angle am I referring to here? I'm referring to the right angle. So side angle side. They both have the same length sides, and they both have the right angle. And they're, in fact, we know the hypotenuses are the same too. So we could also use side. It doesn't really matter. So we could use side here. Namely, what I'm trying to show is that these two are the same. So these are equivalent triangles. So therefore they have the same interior angles. Okay, so what do I know about a straight angle? Let's recall. Straight angles. Angles measure 180 degrees. Okay. The straight angle is the angle of a straight line, right? 2 quadrants, 180 degrees. Okay. So let's say we're asked to find a middle angle here. What shall I call it? Theta. Or let's call it phi. So I want to find phi, which is in between these two. So do you agree that alpha plus beta plus phi should be 180 because that's a straight angle? But what do I know about alpha plus beta? What color shall I use? Orange. I know that alpha plus beta must be 90 degrees because that's the sum of the other two angles in a right triangle. So we have 90 degrees plus phi is 180. So we need to justify the step we did. So this is because alpha plus beta. I'm going to have to do an asterisk. I don't have enough room. Or maybe I do. I can zoom in, make it small. So this is because alpha plus beta plus the 90-degree angle we have inside both of those triangles. Well, we know the interior sum is always 180 degrees. So if I subtract 180 degrees, so let me make this smaller and then move this to the left. So if I subtract 90 degrees from both sides, I'm just left with alpha plus beta is 180 minus 90, otherwise known as 90. So that's how I can do the replacement there, because these are both inside a right triangle, and they're the two angles within that right triangle. So that's what allows me to replace alpha plus beta with 90. So I'm going to do the same thing I just did. What is 180 minus 90? It is 90. So the angle between these two is 90 degrees. So we'll get to what the definition is in a moment. But before I do so, let's note something in a darker green. So note. Slope of line L was given by, let's call it little m sub L, rise over run. Well, from the origin, I rose 4 and ran 3. Whereas the slope of line N was given by, let's call it m sub N. And from the origin, I rose 1, 2, 3, and I ran a -4, so -3/4. Okay, so we have this off to the side. So now let's consider something else. It'd be all right, consider it again. So another x and y coordinate axes. So let's have a line L going through the origin. So line L, and this one is also a 3, 4, 5 right triangle, not that it matters. But actually let me indicate that we rise 3, run 4, not that it matters. Okay, so we're going to rise 3, run 4. But let's consider another line, let's call it N, that also rises 3 and runs 4. So this also has a rise 3, run 4 slope. Okay. Oops. So what do I know about these lines? Meaning, what is the angle between them? Will they ever meet? Well, alternate interior, if two lines are cut by a transversal, then alternate interior angles are equal if these lines do what? Namely, if they're parallel. So, let's just note that these lines never meet. So note, these lines have the same slope, right? Have the same slope. The same slope. So the slope of line L is equal to the slope of line N, but different y-intercepts, right? The first one has a y-intercept of 0, the other one of 2, right? Okay, so these are going to be called parallel. So let's define what I just used. So definition. Finally, we can define what I just did. So definition. Definition. Okay. Okay, so definition number 1. So two lines. Two lines are, actually let's name them. Two lines L and N are parallel. So that's what we're defining, parallel. Denoted by L and two lines. Oh, shoot. Hold on, I'll be right back. I thought we had a power outage there. Okay, I'm back. So denoted by L, two up and down lines, N, if what? They have the same slope. They have the same slope. Yet different y-intercepts, and that's the whole caveat for that one. So that's parallel lines. But what about the other one. So here, the bottom one was parallel. But what do we call the top one? So that's the second definition. So 2 lines, L and N, are perpendicular. Perpendicular. That's what we're defining. And another way to define perpendicular or orthogonal. Orthogonal is another word for perpendicular. Orthogonal. If their slopes, Their, their slopes are negative reciprocals, of one another. So the notation for perpendicular is L and then a square N. So it's like an upside down capital T. So let's note something about perpendicular lines. So note, if L is perpendicular to N, note what I'm saying versus what I'm writing, then this implies they meet at 90 degrees, right? Okay, so let's look what we have up here. Do you agree that that phi we found was a 90-degree angle between the two? So that means that those 2 lines, blue line and purple line, meet at 90 degrees. And their slopes were each one was flipped over and negative of the other. So these two have negative reciprocals. Slopes, so negative reciprocals, meaning we flip it upside down and make it the negative sign. Reciprocals. If it's positive, it becomes negative. If it's negative, it becomes positive. And we flip it upside down. Okay, so given that, so let's do a theorem before we do any examples. So theorem. Yeah, sorry for all the breaks today. We've had lots of electrical issues today. So let's let f of x equals to m1x plus b1 and g of x equals to m2x plus b2. Be linear. Of course, that's redundant. Of course, they're linear by construction. So number 1, f of x is parallel to g of x, means that slope 1 is equivalent to slope 2. Number 2, f of x is perpendicular to g of x, so upside down capital T. This implies that slope 1 is minus 1 over slope 2. Flip it upside down, make it negative. Okay, so for example, and this will be the last 3-part example here. So for example, let's find parallel and find parallel and perpendicular lines through the following. So through the following. Number 1. Let's say we're given that f of x is 2/3 x plus 1. So let's do part A. Let's do parallel through 0, 3. Okay. And then we'll do perpendicular through a different point. So do you agree that my slope parallel will be equal to slope given, which is going to be 2/3. So I know the slope I'm going to use is 2/3. So I have a slope and I have a point. So I'm going to use the point slope form of a line. Namely, y minus y given is slope m times the quantity x minus x given. So y minus y1 is equals to m times the quantity x minus x1. Let's copy, actually, I'll just rewrite it. So we have y minus, so what was the given point? The given point was 0, 3. And we found the slope that's parallel will be the same as the slope that's given. So it's just going to be, when all is said and done, y is equals to 2/3 x, and then I'm going to add 3. Okay, and let's see if that's true. So what I'd like to do is I'd like to plot these to make sure it's true. So x and y, let's do 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'll just plot the first one just to satisfy my curiosity. So f of x has a y-intercept of 1 and a slope of rise 2, run 3. So therefore, it's going to look something like so. So here's my f of x. Now I claim that a parallel line is going to have a y-intercept of 3 and a slope of rise 2, run 3. Is that true? Does that look like it's parallel? And it does. So we'll call this line line parallel. So now part B of this number 1. Let's find the perpendicular line through 0, 1. Okay, for perpendicular lines, let's use, so slope perpendicular is going to be -1 over slope given. So that's going to be flip the slope that's given upside down and make it negative. So -3/2. And now my new point that's given is 0, 1. So what color shall I use? Let's use green. So we have y minus y given is equals to slope m times the quantity x minus x given. So, yeah, I'll just write it explicitly with color coding. So plugging in, I will get y minus y given. The slope was -3/2, and the point given, of course, was 0, 1. Okay, so when I solve for y, let me move this up one so I can have it on the same page. Y is going to be equal to -3/2 x. And I'm going to add 1 to both sides, so +1. So the y-intercept is 1. 0, comma 1 in fact. And I rise in -3 and I run 2. Rise in -3 and run 2. So let's draw this line and see. Is this a perpendicular line? It appears as though it is. It appears as though the angle between the original blue and the green is 90 degrees. So they are orthogonal or perpendicular. Okay, so let's do another one. So number 2. Let's say you're given that f of x is -1/2 x plus 4. So part A, let's find, how did I write it? Yeah, a parallel line through 4, comma 2. Okay, so I know that parallel slopes are going to be the same as the slope that's given. So in this line, it's -1/2. And I know that the point is 4, comma 2. So using the point slope form of a line, y minus y given is equal to slope m times the quantity x minus x given. Okay, so what does that give us? That gives us y minus, the point was 4, comma 2, so this will be y minus 2. The slope we found was -1/2 times the quantity x minus 4. So we get y minus 2 is equal to -1/2 x plus 2, right? Because half of 4 is 2. Now let's add 2 to both sides. So I get that y is equal to -1/2 x plus 4. So that, let's go ahead and plot this one. I won't plot the next one, but just to make sure we're doing this right. So x and y. Let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. Okay, so the original function had a y-intercept of 1, 2, 3, 4, and a slope of rise in -1, run 2. Okay. So here's my original f of x. But now let's look at a parallel line, pink, that through 4, comma 2. Did I not write 4, comma 2? Okay, I made a mistake because this is not a parallel line. This is going to be the same line. It's exactly the same line. So although it appears to have the same slope, so this is line parallel, and we're going to say no. Oops, what's going on? So we're going to say no. Draw a circle around this with a line through it. So this is not parallel. So this is equal to f of x, right? So therefore not parallel. Therefore not parallel. Because it would have to have a different y-intercept, and it doesn't. Okay, let's see if there's a perpendicular. So part B, let's do a perpendicular through 2, 3. Okay, so what about perpendicular slopes? Well, they're negative 1 over the slope given, right? So I flip the given slope, which is negative 1/2, and I make it negative, so it's going to be positive 2 over 1. Once again, the point given now is 2, 3. And what color did I use for I used green. Okay. So y minus y given is slope m times the quantity x minus x given, where the point is 2, 3, so this is y minus 3, and we found the slope to be 2. So this gives us y is equal to, or y minus 3 is equal to 2x minus 4. Let me put the 2 there. And now let's go ahead and add 3 to both sides, so y is equal to 2x. And that's going to be minus 1. Okay, so let's see, the y-intercept is negative 1. And I rise 2, run 1, rise 2, run 1. Okay, it appears to work. Let's see what happens. This does indeed look like it's a 90-degree orthogonal or perpendicular angle. Oh boy. If I could draw it with this autocorrect, it's supposed to make it my life easier, but it doesn't want to draw it. Okay, never mind. I'll just freehand. Good enough for government work. Okay, so there we are. I was going to do another one. Should I do another one? Okay, let's do another one. What the heck? Without drawing it. So let's have f of x be equals to 4/5 x minus 7. So part A, let's do the parallel through 10, now let's see, 10, 2. Okay, so I know that the parallel, what color do I use? So this parallel slope is just the same as what's given. So that's going to be 4/5. And my point is 10, 2. So it's going to be y minus y given is slope m times the quantity x minus x given, where the point is 10, 2, and the slope is 4/5. So we get that y minus 2 is going to be 4/5 x, from which we're subtracting. 5 goes into 10 twice. 2 times 4 is 8. Now let's do that in blue. And now let's go ahead and add 2 to both sides. So we get that y is equal to 4/5 x. 4/5 x. Negative 8 plus 2 is going to be a negative 6. Now notice that's only one away, but that is indeed parallel because it's not equal to f of x. It's got a different y-intercept, so we're okay. As opposed to here where we had the same one, and that was the problem. Right. Okay, so part B, let's do the perpendicular through. Let's do -5, -11. So I know that the perpendicular slope, which I should do in orange. So the perpendicular slope is going to be the negative reciprocal of the one given. So I flip the one that was given upside down, which is 4/5, make it negative 5/4. And my point is negative 5, negative 11. So we get y minus y given is going to be slope m times the quantity, x minus x given. So we have y minus a negative 11, so y plus 11 is going to be negative 5/4 times the quantity x plus 5. Okay, so we get y plus 11 is going to be negative 5/4 x. And now here comes a really ugly part. This is unfortunately going to be negative 25/4. There's nothing we can do about it. Let's go ahead and move this over here. So we end up with y is equal to negative 5/4 x. So we have minus 25/4, minus 25/4, but I'm going to subtract 11. And I claim that subtracting 11 is 44/4. So when all is said and done, we get this ugly y is equal to negative 5/4 x. And let's add 44 and 25. So 40 and 20 is 60. 5 and 4 is 9. So I claim we'll get negative 69/4. And there we are. There's nothing more. I'll see you in the next section.